After reflection of light at curved surfaces, we will see next part. When you are incidencing, you are tabulating a table here, right? You'll observe that at certain angle of incidence, the reflected ray does not comes out. It will separate air and glass. Already we studied this one. Measure the angle of incidence to this situation. The angle of incidence is known as critical angle. The angle which is making the separation of air and glass, that angle is called as critical angle. Let us consider the light ray that travels from medium 1 with refractive index n1 to medium 2 with refractive index n2. See the figure. It is traveling and it is reflecting. Okay. It is already found that angle of refraction is more than angle of incidence. When the light ray travels from denser to rarer, for the angle of incidence I, let R be the angle of reflection. From Snell's law, n1 sin I is equal to n2 sin R. This implies n1 by n2 is equal to sin R by sin I. We know that n1 by n2 is greater than 1, so that sin R by sin I is also greater than 1. So we conclude that the angle of refraction is greater than angle of incidence, that is R greater than I. Angle of incidence at which the light ray traveling from denser to rarer medium gazes the interference is called critical angle for denser medium. It is shown in figure 7. This angle is called critical angle. Okay. Let C be the critical angle. Then R becomes 90. We get N1 by N2 is equal to sin 90 by sin C. N1 by N2 is equal to sin 90 value is 1. This you will study in next 10th class by sin C. Okay. We get sin C is equal to N2 by N1. We know that N1 by N2, that is N1 is called refractive index of denser medium with respect to rarer medium. Sin C is equal to 1 by N12. Can you find critical angle of water using the above equation? Discuss it in your class. What happens to light when the angle of incidence is greater than critical angle? When angle of incidence is greater than critical angle, the light ray gets reflected into the denser medium and the interference. Light never enters the rarer medium. This phenomena is called total reflection. Total internal reflection. The light which is passing, which is greater than critical angle, then the light will get reflected into denser medium. Okay, it won't go into rarer medium. This phenomena is called total internal reflection. Discuss these ideas in your class and find out the critical angle of water. Let us see an example on total internal reflection. This we will study in next class. Okay, thank you students.